Hello everyone, welcome back to my YouTube channel Physics Unification. In the last video, we discussed some topics from the electric charges and fields. Those are electric charges, conductors and insulator concept, basic properties of electric charges, Coulomb's law and which is in vector notation, forces between multiple charges, electric field and expression for electric field due to the system of charges, electric field lines and their properties. Last one, electric flux. If you have not seen it, please go through it. I have already attached those links in a description box. Let's continue the next topics from the chapter electric charges and fields. First one, it is electric dipole. It can be defined as pair of equal and opposite point charges. That one is plus q and another one it is opposite charge minus q, which is separated by a small distance to a. That is P is equals to electric dipole P can be written as 2aq into P cap. So magnitude of P can be written as 2aq. SI unit of electric dipole can be written as Coulomb meter. So next one it is electric field of an electric dipole. There are two cases are there. When it is placed on the dipole axis, and second case when that same point which is on the equatorial plane of the dipole. Let's see the first case, and these two cases are very important for the 5 marks derivations. First one, it is electric field of an electric dipole at the points on the axis. That one is axial point. P be a point at a distance r from the center of the dipole. Complete center ಇಂದ ನಾವು r distance ಅಲ್ಲಿ P point ಅನ್ನ imagine ಮಾಡ್ಕೋತೀವಿ. On the side of the charge plus Q. Electric field due to the charge Q at a distance d from it can be written as 1 by 4 pi epsilon naught Q divided by d square. Now what we have to do? We have to apply electric field due to minus Q at the point P. Can be written as E minus Q is equals to 1 by 4 pi epsilon naught minus Q illide minus Q divided by ಈ P ಇಂದ minus Q ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ ಏನು R. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಡಿಸ್ಟೆನ್ಸ್ A, ಎಕ್ಸಾಕ್ಟ್ ಹಾಫ್. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ ಮತ್ತೊಂದು A. ದಟ್ ಒನ್ ಈಸ್ R plus A whole square P cap. So negative sign indicates the E minus Q which is opposite to P cap. Electric field due to plus Q at P is at P by the charge plus Q can be taken it as E plus Q is equals to 1 by 4 pi epsilon naught Q divided by, this one is the total distance R minus half distance we have to take, that one is A, R minus A whole square P cap. Therefore, total electric field can be taken it as E is equals to E plus and E minus, means that one is the sum of E plus and E minus Q. E is equals to E plus Q, it is 1 by 4 pi epsilon naught Q divided by R minus A whole square P cap plus E minus Q, it is 1 by 4 pi epsilon naught minus Q divided by R plus A whole square P cap. Here from the both the quantities 1 by 4 pi epsilon naught into Q is the common, just take outside. Then inside the bracket we will get 1 divided by R minus A whole square minus, why minus? Here plus into minus which gives the value of minus. 1 divided by R plus A whole square into P cap. So E is equals to Q divided by 4 pi epsilon naught. Just take LCM of R minus A whole square and R plus A whole square, means which gives direct cross multiplication of those values. So which gives R plus A whole square minus 1 into R minus A whole square divided by those two, multiplication of those two quantities, R minus A whole square into R plus A whole square P cap. Now E is equals to Q divided by 4 pi epsilon naught A plus B whole square formula. We already know it is, that one is A square plus B square plus 2AB. In place of A they are given R, in place of B they are given A. So r square plus a square plus 2ra minus of r square a minus b whole square formula. That means a square plus b square minus 2ab. R square plus a square minus 2ra whole divided by r minus a whole square r plus a whole square p cap. Next, E is equals to Q divided by 4 pi epsilon naught R square. Just remove those brackets, then we will get R square plus A square plus 2RA minus into plus minus R square minus into plus minus A square minus into minus plus 2RA whole divided by R minus A whole square R plus A whole square P cap. Now E is equals to Q divided by 4 pi epsilon naught. Here r square minus r square gets cancelled. A square minus a square gets cancelled. Plus 2ra which gives 4ra divided by r minus a whole square r plus a whole square p cap. Now E is equals to Q divided by 4 pi epsilon naught 4ra divided by a minus b whole square a plus b whole square can be written as a square minus b square whole square. In place of r minus a whole square r plus a whole square, what we can write? R square minus a square whole square into p cap. Now total electric field E can be written as Q divided by 4 pi epsilon naught 2r p, because vector p, that one is electric dipole, can be written as 2aq into p cap. So here 4ra means 2aq we will get here. P is equals to 2aq into p cap. So E is equals to 1 divided by 4 pi epsilon naught 2r vector p, that one is electric dipole, divided by r square minus a square whole square. At very large distances, r is very much greater than a. So those cases, what we will get? E is equals to 1 divided by 4 pi epsilon naught, same as it is idanne barkotivi, 4a q r into vector p divided by r is very much greater than a means ನಾವು ಇದನ್ನ ಹೇಗೆ ತಗೋತೀವಿ? r square which is greater than a square. R square minus a square whole square can be nearly equal to r to the power of 4. ಇಲ್ಲಿ r to the power of 4 ಅಂತ ಬರ್ಕೋತೀವಿ. ಈ ವ್ಯಾಲ್ಯೂ ಇರೋ ಜಾಗದಲ್ಲಿ r to the power of 4 ಬರ್ಕೋತೀವಿ. 1 r ಮತ್ತೊಂದು r cancel each other, then we will get 1 divided by 4 pi epsilon naught 2aq, that one is vector p, into remaining quantity is 2 divided by r cube. It is total electric field on the axial point is equals to 1 by 4 pi epsilon naught 2 into vector p divided by r cube. This derivation is very important for 5 marks in the final examination. Next derivation is electric field of an electric dipole at the point on equatorial plane. This one is also very important for 5 marks. Let us consider two charges plus q and minus q, which is separated by a distance of 2a, and p be a point at a distance of r from the center of the dipole. Using Pythagoras theorem, what we can write? D is equals to square root of r square plus a square. That is, D is equals to square root of r square plus a square. Here AP which is equals to BP which is equals to value of D. An electric field due to a charge Q at a distance D from it can be written as E is equals to 1 divided by 4 pi epsilon naught Q divided by D square. Now magnitude of the electric field at P due to the charge plus Q ಇಂದ ಕ್ರಿಯೇಟ್ ಆಗಿರೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ನ ಬರೀಬೇಕು. ಹೇಗೆ ಬರಿತೀವಿ? ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ E plus Q is equals to 1 by 4 by epsilon naught, same as it is, plus Q divided by D, value is square root of R square plus A square. That is D square value, it is 1 by 4 by epsilon naught Q divided by R square plus A square. In place of D square, what we can write? R square plus A square directly. Now magnitude of electric field at P due to the charge minus Q can be written as E is equals to minus Q, which is equals to 1 by 4 by epsilon naught Q divided by R square plus A square. Minus Q ಯಾಕೆ ಬರೀಲಿಲ್ಲ? Magnitude sign ಹಾಕಿದ್ರೆ we will get positive sign only. So now what happens? Components normal to the dipole axis, that one is E plus sin theta and E minus sin theta. Those two quantities are cancel out each other as they are equal in magnitude and opposite in direction. The components parallel to the dipole axis E plus Q and E minus Q add up each other. That is E is equals to E plus Q, E minus Q cos theta into minus P cap. Here electric field P, and now E is equals to E plus Q value is 1 by 4 by epsilon naught Q divided by R square plus A square plus E minus Q value 1 by 4 by epsilon naught Q divided by R square plus A square into cos theta P cap. Minus sign ಇದ್ದಿದ್ದನ್ನು ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇ ಹಾಕೋತೀವಿ. Then we will get E is equals to minus of this quantity plus this quantity, we will get to Q divided by 4 by epsilon naught R square plus A square into cos theta P cap. Here by the diagram, cos theta can be written as AO divided by AP. Value of AO is A divided by square root of value of AP is square root of R square plus A square. So therefore E is equals to minus 2Q divided by 4 by epsilon naught R square plus A square. In place of cos theta, what we have to write? A divided by square root of R square plus A square into P cap. E is equals to minus 2AQ divided by 4 by epsilon naught R square plus A square. Here it is 1 by 2, here it is 1. 1 plus 1 by 2 is 3 by 2. That one is R plus R square plus A square raised to 3 by 2 P cap. And this can be written as minus electric dipole P, because electric dipole can be written as P is equals to 2AQ divided by 4 by epsilon naught R cube. Why? Here R is very much greater than A. That's why we can take it as R square. This is very much greater than A square. ಇಲ್ಲಿ ನಾವೇನು ತಗೋತೀವಿ? R to the power of square whole to the power of 3 by 2 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Square 1 by 2 cancel each other and we will get R cube only. Therefore electric field E is equals to minus P, that one is electric dipole divided by 4 pi epsilon naught R Q. Here electric field of a dipole at large distances in simpler forms can be written as in first case, at a point on the dipole axis, at a point on the dipole axis, E can be written as 1 by 4 pi epsilon naught 2p divided by r cube. In second case, at a point on the equitorial plane can be written as E is equals to 1 by 4 pi epsilon naught minus p divided by r cube. Next concept, it is dipole in a uniform external field. That one is the derivation for expression for the torque. Here P be a dipole moment which is in a uniform external field, that is E. Force on plus Q can be written as F1 is equals to Q into E. Force on minus Q can be taken it as F2 is equals to minus Q into E. Here net force on the dipole is 0 because external field E is uniform. Then magnitude of torque can be written as force into perpendicular distance. Force, it is Q into E. Perpendicular distance is 2a into sine theta. Therefore, torque tau is equals to 2aq E sine theta. We know 2aq can be written as P, dipole moment P, into E sine theta. In vector form, tau can be written it as tau is equals to vector P into vector E. Torque is maximum when theta is 90 degree. Then dipole moment and electric field are perpendicular to each other. Torque is minimum when theta is 0. At that case, dipole moment P and electric field E are parallel to each other. Next concept, it is continuous charge distribution. Here first one, it is linear charge density. It is the ratio of delta Q divided by delta L. Here delta L is the small line element of the wire. SI unit of linear charge density is coulomb per meter because Q is a charge of the certain particles. The dimensional formula can be written as ATL minus 1. Next one, it is surface charge density. It can be defined as delta Q divided by delta A. That is delta A is small area element of the wire. SI unit of surface charge density can be written as charge. That one is coulomb per meter square, and dimensional formula it is ATL minus 2. Third one, it is volume charge density, that is rho. It is equals to delta Q divided by delta V. SI unit of volume charge density is coulomb per meter cube, and dimensional formula it is ATL minus 3. Next one is expression for electric field due to continuous charge distribution. That one is the direct expression. E is equals to 1 by 4 pi epsilon naught summation of all delta V rho. Rho means that one is the volume charge density into delta V divided by R square R cap. Here rho is the volume charge density, delta V is the elemental volume, and R dash is the distance between the charge element, and P, that one is the dipole moment. R dash cap, it is the unit vector in the direction from the charge element top. Gauss law. the flux of electric field through any closed surface, which is equals to the 1 by epsilon naught times the total charge enclosed by that surface S. That is, flux phi is equals to 1 by epsilon naught times Q. Here total electric flux through a closed surface is 0 when if there is no charges enclosed by that surface. Next one, it is application of Gauss law. There are mainly three applications are there. First one, it is derivation of the expression for the electric field due to an infinitely long straight charged wire. Electric field ಅನ್ನ ಡ್ರಾ ಮಾಡ್ತೀವಿ just by using Gauss law. Let us consider infinitely long thin straight wire. ಇದು infinitely long thin straight wire ನ consider ಮಾಡ್ತೀವಿ with uniform linear charge density lambda. Just imagine a cylindrical Gaussian surface. ಇದೊಂದು cylindrical Gaussian surface ಅನ್ನ imagine ಮಾಡ್ತೀವಿ where field is constant, that one is radial. Flux through the two ends of the cylindrical Gaussian surface is 0. Now flux can be written it as flux is equals to, means flux through the Gaussian surface can be written it as flux phi is equals to flux through the cylindrical part of the surface. It is E into area of that cylinder. Flux phi is equals to E into area of the cylinder ಹೇಗೆ ಬರಿತೀವಿ 2 pi RL. That one is the area of the cylinder. Now we know linear charge density can be written it as, that one is the ratio of charge per unit length. Just by using that one, surface includes the charge can be written it as Q is equals to lambda into L. From Gauss law, what we can write, flux is equals to 1 by epsilon naught times the total charge through that surface. So flux phi is equals to, by equation 1, flux phi can be written as E into 2 pi RL. ಆ ವ್ಯಾಲ್ಯೂನ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ, which is equals to value of Q by equation 2 can be written it as lambda into L divided by epsilon naught. LL gets cancelled and what we will get, electric field can be written it as E is equals to lambda divided by 2 pi epsilon naught into R. So finally E is equals to 1 by 4 pi epsilon naught 2 lambda divided by R. This one is the expression for electric field due to an infinitely long straight charged wire. This one is the first application of Gauss law. And this derivation is very important for 5 marks. And that vectorically electric field at any point at a distance r from the charged wire can be written it as E is equals to lambda divided by 2 pi epsilon naught into r n cap. Here n cap is the unit vector. Okay, up to here that one is the derivation for electric field through the electrically charged wire, long straight wire. Next one, it is a derivation of the expression for the electric field due to an uniformly charged infinite plane sheet. Let us consider sigma. That sigma, it is the uniform surface charge density of an infinite plane sheet. Let's just imagine a Gaussian surface of rectangular parallelepiped of cross-sectional area A. ಇಲ್ಲಿ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಪ್ಯಾಲೋಪಿಪೆಡ್ನ ನಾವು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ತೀವಿ, ದಟ್ ಒನ್ ಇಸ್ ದಿ Gaussian ಸರ್ಫೇಸ್. ಅದರ ಏರಿಯಾ ಎ ಇದೆ ಆ್ಯಂಡ್ ಓನ್ಲಿ 2 faces 1 and 2 will contribute the total flux. So flux can be written it as E into delta S. Therefore the net flux through the Gaussian surface can be written it as flux phi is equals to E into A, actually it is, but which contributes 2 faces, means 2 faces which contributes the flux, so which gives 2 into EA. That one is the first expression. Charge enclosed by the closed surface can be written it as Q is equals to sigma into A. We know that one is surface charge density can be defined it as, it is the charge per unit area. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಯೂಸ್ ಮಾಡಿ ನಾವು ಚಾರ್ಜ್ ಜನ ಹೇಗೆ ಬರಿತೀವಿ, ಸಿಗ್ಮಾ ಇಂಟು ಎ ಅಂತ ಬರಿತೀವಿ. ಫ್ರಮ್ ಗಾಸ್ ಲಾ ಫೈ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಇಟ್ ಆಸ್ Q divided by epsilon naught. Just substitute value of phi, that means 2EA in equation 3 on left hand side. Then what we will get, 2EA, which is equals to, by equation 2, Q can be written it as sigma into A. Sigma into A divided by epsilon naught. Here A gets cancelled, and at the finally we will get E is equals to sigma divided by 2 into epsilon naught. This one is the expression for electric field for the uniformly charged infinite plane sheet. Vectorically, the electric field due to an uniformly charged infinite plane sheet can be written it as E is equals to sigma divided by 2 epsilon naught into n cap. And this one is also important for 5 marks. Next one, it is derivation of the expression for the electric field due to an uniformly charged thin spherical shell. Here there are two cases are there. First one, it is field outside the shell. This one is the point P, which is outside the shell with the radius vector r. The electric field at each point of the Gaussian surface has the same magnitude. Electric field ಆ Gaussian surface ಅಲ್ಲಿ ಹೇಗಿರುತ್ತೆ, same magnitude ನ ಹೊಂದಿರುತ್ತೆ, and which is along the radius vector at each point. Here electric field E and area element delta S at every point are parallel to each other, and the flux through the each element is, ಆ flux ಅನ್ನು ನಾವು ಹೇಗೆ ಬರಿತೀವಿ, flux is equals to, we know E delta S cos theta actually. Here theta is 0. Why? Here electric field and delta S are parallel to each other. Parallel ಇದ್ದಾಗ ಏನಾಗ್ತದೆ, theta 0 ಆಗಿರ್ತದೆ. Cos 0 it is 1. Then electric flux delta phi can be written it as E into delta S. Therefore, total area of Gaussian surface can be written it as 4 pi r square. That one is area of the circle, 4 pi r square. Therefore, total flux can be written it as phi is equals to E into delta S ಇರೋ ಜಾಗದಲ್ಲಿ ನಾವು ಏನನ್ನ ಬರಿತೀವಿ, 4 pi r square ನ substitute ಮಾಡ್ತೀವಿ. After that, from Gauss law, we know electric flux, which is equals to the 1 by epsilon naught times the total charge Q. Here, just substitute the value of phi. That one is E into 4 by r square in equation 2. Then what we will get, E into 4 by r square, which is equals to Q divided by epsilon naught. That is, electric field E can be written it as Q divided by 4 by epsilon naught into r square. Vectorically, electric field can be written it as 1 by 4 pi epsilon naught into Q divided by r square into r cap. Total charge on the spherical shell, it is Q is equals to sigma into A. Sigma into area of the circle, it is 4 pi r square. Therefore, sigma can be written it as Q divided by 4 pi r square. Electric field on the surface of spherical shell of radius r, now it can be written it as E is equals to 1 by 4 pi epsilon naught Q divided by r square, and we know sigma is equals to Q divided by 4 by r square. ಆ ವ್ಯಾಲ್ಯೂನ ಇದರೊಳಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ what we will get finally, E is equals to sigma divided by epsilon naught. Next case, it is field inside the shell. ಆ ಪಾಯಿಂಟ್ P ಆ ಶೆಲ್ ಒಳಗಡೆನೆ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, let P which is inside the shell. The flux through the Gaussian surface can be written it as phi is equals to E into 4 pi r square. The charges are present only on the surface of the ಶೆಲ್. ಇನ್ಸೈಡ್ ದಿ ಶೆಲ್ ಇದ್ದಾಗ ಫೀಲ್ಡ್ ಏನಾಗಿರುತ್ತೆ, ಆ ಚಾರ್ಜಸ್ ಆ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ ಶೆಲ್ ಮೇಲ್ಗಡೆ ಮಾತ್ರ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ. ದ ಗೌಷನ್ ಸರ್ಫೇಸ್ ಎನ್ಕ್ಲೋಸಸ್ ನೋ ಚಾರ್ಜ್. ಆ ಗೌಷನ್ ಸರ್ಫೇಸ್ ಒಳಗಡೆ ಯಾವುದೇ ಚಾರ್ಜಸ್ ಇರುವುದಿಲ್ಲ. ದೆನ್ ಫ್ರಮ್ ಗಾಸ್ ಲಾ that can be written as phi is equals to q divided by epsilon naught, which is equals to 0. That is phi is equals to 4 pi r square into e. Equation 1 ಇಲ್ಲಿ substitute ಮಾಡಿದ್ರೆ which is equals to 0. Then electric field inside the shell which is equals to value 0. Means E is equals to 0 here. Here R is very much less than radius of that shell. Here electric field due to an uniformly charged thin shell is 0. Electric field a uniformly charged thin shell ಇಂದ ಕ್ರಿಯೇಟ್ ಆಗಿರೋದು ಏನಿರುತ್ತೆ, 0 ಇರುತ್ತೆ at all points inside the shell. ಅಂದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇನ್ಸೈಡ್ ದಿ ಶೆಲ್ 0 ಇರುತ್ತೆ, ಔಟ್ಸೈಡ್ ದಿ ಶೆಲ್ ವಾಟ್ ವಿ ವಿಲ್ ಗೆಟ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಸಿಗ್ಮಾ ಡಿವೈಡೆಡ್ ಬೈ epsilon naught. Outside the shell electric field it is sigma divided by epsilon naught. Inside the shell 0. And this one is the derivation for the expression for electric field by the shell, which completes the chapter electric charges and fields. What we discussed in this video, first one it is electric dipole. That one is P is equals to 2AQ. Second one, expression for electric field of an electric dipole on the axis. Here electric field of an electric dipole on the equatorial plane. And next, derivation of expression for torque. And next one it is continuous charge distribution, in which first one linear charge distribution, surface charge distribution and volume charge distribution. After that, Gauss law and its application. Totally from this chapter 1 marks, 2 marks and 5 marks questions will come for the final examination. Thank you. Stay tuned, like, share and subscribe my YouTube channel Physics Unification.